Hello, welcome to Code with Richard, and in this episode, I'm going to solve LeetCode problem number 19, remove nth node from the end of list. So right over here, I copied and pasted from LeetCode the problem statement. Given the head of a linked list, remove the nth node from the end of the list and return its head. And it also provides a couple of examples. So example number one, here is the input, it's the linked list with nodes 1, 2, 3, 4, 5, and n is 2. And so it wants us to remove this 4 right here, which is the second element from the end. And here's that output. Here's another example, 2. If there's just one element and n is 1, we're just going to remove all the elements and there'll be no output. And then here's another example, example 3, where n is 1. So the first element from the end of the list is 2, and I'll just return a list with just 1. And it does give us a definition for a singly linked list where each node contains a value and a next pointer. Okay, so let's get started. And I'm going to show you my approach to how I solve the problem. And one of the things that I realized is that there's 3 cases as we traverse the list. And the first case is we're going to remove the nth node, which is not the first node in the list. And we'll see why there's a case for that. So likewise, we'll say case number 2 is remove the first node from the list. And then case number 3 is, I'll just call it invalid node to remove. So let's say this n is 100, but we don't even have 100 elements in the list, and there's no way that we can remove it. And the other thing that I forgot to mention is that the LeetCode hints, or they actually suggest doing this in one pass, and they also hint of keeping multiple pointers as references into the list. And that's actually the strategy that I decided to use to solve this. So let's do some examples on this case number 1. So let's assume that n is 1. So we're going to remove the last element in the list. And let's just create a linked list where 1 is our head and it points to a node 2, and then that points to a node 3. And then I'm just going to put an arrow here showing that it points to nothing because next is none. So in this particular case, my n is 1. And I'm just going to put a note up here. My target node to remove is 3. Because if n is 1, then that means the element at the very end we want to remove. Likewise, n is 2, we want to remove the second to last. If n is 3, we want to remove 1. And I decided to keep 3 references to this list. The first one I'm just calling H, which is head. And it's always going to be pointing to the first element in the list. And this is going to be important because if we remove the first element in the list, we need a reference to change. We need a reference to that first element. I'm going to keep another pointer called T, and my T is just I'm going to call it my trailing node. I'm going to call another pointer called I, which I'm going to call my incrementing. And so I'm going to say that right here, my H, my T, my I, each of these 3 pointers all point to the first element of my list when we start. And my strategy is this incrementing node is going to move from 1 to 2 to 3 and so on and so forth until the trailing node and the incrementing node are n nodes apart. And that we'll use to help us find the nth node from the very end, because we will not be able to determine which node is the nth node until we actually hit the end. Okay, so what else do we need? And I'm also going to create a variable called TB, and I'm going to TB equals trailing by. And actually, my TB is 0, because what this represents is a distance in nodes between my incrementing node and my trailing node. So right now, when we start, it's going to be 0. And the way this is going to work, let's go down here, is let me go ahead and copy these. So we start off with all of our pointers pointing to the first node, HTI, but what we're going to do is we're going to move the incrementing node and point it to the next node. So n is still 1, it's not going to change, but now trailing by is going to equal 1, because now there's a distance of 1 node between my incrementing node here and my trailing node right here. Okay. So this is actually a case that we want, because n is 1 and trailing by 1, we can actually use that. And let's look at some logic. So now we know that my n equals my trailing by, and my incrementing.next is not none. So I can continue because I'm not at the end of the list, and I want to progress I and t. Because remember, I need to find the end of the list first. So I'm going to copy this, and what I'm going to do is I'm going to increment both my I and my t. And so my n is still 1, my trailing is still 1. And now I can do a check. My n equals my trailing by, and my I dot next is none. So now I can actually remove my nth node, or my first node from the end of the list, which is number 3. So I can simply set my t dot next equal to my t dot next dot next. So t dot next is this pointer that points to 3, but I want to remove this 3, so I'll point it to next, which is none. So now 2 will point to none. And I'll just say this will return the head, which is my node with 1, the next node, which has 2, and then this is going to point to none because my next is going to point to my next, which actually is right here, which is none. And that's exactly what we want because our target is to remove node. Okay, so let's go to another example to help walk through. And in this case, let's say our n is 2, and let's take the same linked list here. So I'm going to copy and paste this down here, and I'll just put a note, my target to remove is my node 2. Because remember, n is 1, remove 3, n is 2, remove 2. Okay, and I will have my 3 pointers pointing to my first node, my head, my trailing node, and my incrementing node all point to number 1. And then I will say, well, my n is 2 here, and my trailing by equals 0. Okay, so just like before, I need to increment my incrementing node until my trailing node trails by n nodes. So I can increment my incrementing node, and here my trailing by is trailing by 1. And just do that one more time. So we will increment our incrementing one more time, and now the trailing by is 2. And so in this case, we can just do a check. My n equals my trailing by, and I dot next is none. So I've hit the end of the list. I'm going to set my t dot next equals t dot next dot next. Oops. Oh, I messed it up again. Next, next, just like we did up here, and then we're going to return. So what will this return? For a t.next, the pointer, the next node is my next, so my node 1 will actually point to 3. So this will return node 1 pointed to my 3 node. And this is exactly what we want because we want to remove node 2. Okay, so let's go down to the next case, which is here, removing the first node. And so this is a special case. So let's say we have just a very simple list, which is one node with just this one. Our n equals 1, and so our target to remove is the 1. So again, we have our n equals 1, and then we have a trailing by equals 0. So remember, we have our head pointer here. We were trailing by and are incrementing. But in this particular case, we can't increment it. So if our incrementing dot next is none, and n minus tb equals 1. So this is a special case where we look at the difference between n and our trailing by, and the difference is just 1. We remove the first node. And so we'll return, so how do we do that? Well, we'll set h.next. Oh, I'm sorry, we'll set our head equals to our head.next. So in this case, our head.next is actually none. And this effectively will return none in this particular case. The head will point to none. And let's go to one more example. Let's say we have a slightly larger linked list, which is 2 nodes, and we say our n is 2. So in this case, we want to remove node number 1, and then we'll say our target to remove is 1. So our n is 2. We'll say our trailing by always starts with 0, and our 3 pointers, our head, our trailing node, and our incrementing node all start pointing to. So in this particular case, we can increment the incrementing node. Because there's 2 nodes. So we can increment the I to this next node, number 2. This trailing by is 1. And now we hit this case where I.next is none. Just like before, I.next is none. So we cannot increment this pointer. And in this case, I minus TB equals 1. So we look at the trailing by and the n, there's a difference of just 1 between them. So this is a special case. So we're going to remove the first node, and what we're gonna set the head, or just return the head of the new list. We return h.next because we want to take off the first element of the list, and this will return. So I guess to clarify up here, we should just say, instead of saying h.next, we'll just return h.next, which is that. Because in the case, LeetCode is asking us to return the head of the list. So in this case, since we remove the head and there's none, we're going to return none. And then here, we're actually going to remove the first node and return the new head, which is node number 2. Okay, and so now let's go to the next case of case number 3, which is an invalid node to remove. let's say n equals 10, and let's say we just have one element in the list. So if our n is 10, 10 trailing by a 0, and we'll start off with our 3 pointers to the first node, head, trailing, and incremented node. So we hit this case where I.next is none, and the difference between n and tb is greater than 1, so we're just going to remove the head. And why? Is because we don't remove any nodes. There aren't 10 elements in the list, just return the list, and that's going to be our base case. Okay, so now we can just jump into our implementation. So again, as you review, they gave us this list node definition, and now let's go to remove nth from n. So what is this going to look like? So the first thing we can do is just check, do we even have a list or not? So if our head is none, I'll just return my head and be done with it, or return none. And then I'm going to create my variables. So remember, I start with the head, but I want to create a trailing node and an incrementing node, and this trailing by variable. So trailing by, always going to start off 0. My incrementing node is going to set to my head, and I have a trailing, oops, I have a trailing node is going to be my head as well. So remember, in all these examples, my head, my trailing node, and my incrementing node all start at this very first node, which is my head. Okay. And ideally, in the happy path, what I like to do is keep incrementing my incrementing node until the distance between my incrementing node and my trailing node is equal to my n. So I will call this incrementing node until trailing by equals n. Okay. So I'm going to do this with a while loop. So while trailing by is less than n, we're going to keep incrementing. But the first check I need to make is, can I increment? Because potentially we hit the end of the list before we can actually perform an increment. So can I increment? And the way I can check is if my incrementing node next, which means it's not none. In this case, I'll say yes, it's safe to increment. I'll take my incrementing node and I will just point it to my next incrementing node.next. So in the very happy path that's right up here, we start with our incrementing node at our first node, but because there's a node that exists later, I just move it to the next node. Okay? And once I move it to the next node, then I can update my trailing by. And we'll just add 1. So it's going to be an else. And if this first one is yes, it's safe to increment, this second one is I can't increment, hit end of list. Okay? And remember, there's 2 cases that we need to look at for this. So at the end of the list is I.next is none. So if the difference between our n and our trailing by is exactly 1, then we're going to remove our first node. However, if it's greater than 1, we're just going to return our head. Okay, so we can check to see the difference of our n and our trailing by. So we'll just have an if condition, and we'll just say n minus our trailing by. Remember, if it's exactly 1, then it's a special case. And actually, so if it's exactly 1, then we want to remove our first node. So I can just return our head.next. So whatever that is, if there's another node, it'll return the second node. If there's no node, it'll just return none, and that's fine. Otherwise, we can't remove any nodes. N is too high in this case. If we can't return any nodes, we're just going to return our head. Okay, so now we finish this block of code right here, and this is incrementing our incrementing node until our trailing by is n. And so if we have a really long list and our n is small, we'll reach that pretty quickly, and then now we have to increment both our incrementing and our trailing by nodes. So in this particular case, you can see that our n is 1, so we incremented our incrementing node. Our trailing node is trailing by exactly 1, so we can increment both I and t. And we'll just put a note. We know trailing by equals n, and we want to increment both incrementing node and our trailing node until we hit end of list. So we'll say while incrementing node dot next, because once it's none, then we'll be at the end of the list. But we want to increment both of these, so we have our incrementing node equals our incrementing node dot next, and we'll do the same thing for our trailing node as well. Trailing node equals our trailing node dot next. And now we are at the end of this. And we can remove the nth node. So let's come back up here for an example. And so remember, in this case, we're trailing by 1, our t and our I. We've progressed both t and I to the end of the list. So the next I is none, but t is right here, and we actually want to remove 3. So we're going to set t.next. Instead of pointing it to 3, we want to point it to 3's next, which is none. So trailing node dot next equals the trailing node next. Or because there may not necessarily be the end of the list here. The list could be quite long. If the list, let's say, has 10 elements and you have a small n, then we're just going to increment twice our trailing node. We'll have our trailing node dot next, and if we did trailing node dot next, remember it's just the next node, but that's the one we want to remove, and we'll just go to the next. And we're just going to return our head right here. All right, so now our implementation is done. I went ahead and found a couple bugs. So the first bug, which you might have noticed, is there's a variable that is misspelled. So this is trailing by. And the other thing that I implemented, and this is to help with our testing, is I created a couple extra methods in our list. Our list node. I created a toList method which will convert the list. You give it a head, or you apply this on the head, and it'll convert it to a list of numbers, and I just gave it a string method as well. And so over here I have unit tests for this, and what this represents is this is our input right here. So in this case, 1, 2, 3, 4, 5. We want to remove the first element from the end of the list, which is node 5, and then here is our expected output. So we check every single case here for this list, and then there's a couple other cases, removing the first element of the list, the only element of the list, This is removing nothing because n is too high, and again, removing nothing because n is too high. And if I go over here, so you can see these are some of the error messages that I got to help me double check. And now I run my unit tests and everything looks good. So thank you so much for joining me in this episode of Code with Richard on this LeetCode problem. If you have any questions, please leave them as comments in the video. If not, I hope to see you next time. Thanks. Bye.